At the Chi 94 conference, we presented a new style of graphical user interface, the see-through interface. On a computer display, see-through tools appear on a semi-transparent sheet that can be positioned over applications using either hand. The tools are applied by clicking through them with a cursor controlled by the dominant hand. This video quickly reviews the see-through paradigm and then illustrates a taxonomy of see-through tools with examples from graphical and text editing.
You are looking at the screen of a Sun SPARC 10 running the Cedar programming environment. This SPARC is equipped with a mouse for the user's dominant hand and a trackball for the user's other hand. This region of the screen contains a simple window system that we use to demonstrate a variety of see-through tools. The see-through interface consists of a movable transparent sheet called a tool glass sheet that transports a collection of tools. Here, we move the tool glass sheet with the non-dominant hand using the trackball, while we move the cursor with a mouse. See-through tools allow a user to specify an operation to apply and an object to apply it to, all in a single gesture. For example, we can position these color-changing buttons over an illustration. Clicking on a shape through the red button makes that shape red. Clicking through the blue button makes a shape blue, and similarly for other colors. In the rest of this tape, each scene emphasizes a different attribute of see-through tools and shows how that attribute varies from tool to tool.
At any point in time, a tool glass sheet may contain a mixture of tools, some of which the user clicks through and some of which the user clicks on. For example, this sheet displays a configurable graphical filter at its center. These click-on buttons at the top select a filter shape, such as the Xerox logo, or a circle. The click-on buttons at the bottom select a filter type, such as neon, or scale. The click-on slider on the left can adjust a lens parameter, such as the magnification of the scaling lens. This click-on button toggles the menu visibility. Our click-on buttons are opaque to make them visually distinct from click-through buttons. On the other hand, the lens itself is a see-through tool. Mouse actions through this lens allow underlying objects to be positioned with the aid of magnification. See-through tools can be triggered in many ways. For example, this tool, a shape palette, is triggered by pressing down a mouse button over a desired shape, moving the mouse to position the shape, and then releasing the mouse button. This tool is used to pick up and apply graphical properties. The square in the lower left of the tool is a prototype, showing the graphical properties that are ready to be applied. The tool is triggered by drawing a stroke from one tool region to another. To apply the fill color of the prototype to the giraffe body, we press a mouse button on the region labeled fill color, move to the body, and release the mouse button. Likewise, to change the dash pattern on a giraffe spot, we begin our stroke on the dashes button and move to the spot. By stroking in the other direction, we can pick up graphical properties. For example, if we stroke from this giraffe spot to the button labeled all properties of the spot are applied to the prototype. The properties can be transferred to other shapes by stroking from all to the shapes. The next tool is a gesture interpreter. It recognizes letters of the alphabet expressed in David Goldberg's Unistroke gesture language. Unistroke letters made from this text tool cause the corresponding letters to be added to our illustration. The same gestures in the lower region are interpreted as editing commands. For example, we use T for translate, C for copy, then translate, and D for delete. Tools may differ in the way data flows between the tool and the application. For instance, when a clipboard tool picks up an object, data flows from the application to the tool. On the other hand, when a clipboard drops an object, data flows from the tool to the application. While many tools transfer only a small amount of information, they may also transfer a large amount of information. For example, this tool is a file directory browser. Clicking on one of the blue icons in the browser causes that file to be loaded into the application window. Some tools work over a single application, while others work over multiple applications. Our color editing tool can pick up a color in this graphics window, modify it, and apply the resulting color to a word in this text editor. One unusual application uses see-through tools to perform operations on traditional control panels. Here's a traditional control panel that performs graphical editing operations. We can change the color of this purple house by selecting the house and then clicking on a color changing button in the control panel. We can move that house to the front of the scene by clicking on the overlap button. This is a macro tool. We can use it to pick up copies of the buttons from our traditional control panel, such as the blue color changing button and the overlap button. Then, by clicking through the lower part of the tool, we select a shape and apply both buttons to it, just as if we had clicked on each button in turn. Tools may change the appearance of the application seen through them in order to enhance the tool's function. This tool shows an X-ray view of the shapes underneath it. With this tool, it is easy to select corners that are hidden behind other shapes, such as the tip of this petal or the tip of this blade of grass. Tools may also be semi-transparent. For example, this tool has the appearance of blue tinted glass. It changes the line width of objects underneath. We click on a thick rectangle for a thick line and a thin rectangle for a thin line. Most see-through tools move rigidly with the tool glass sheet. Others move relative to the sheet, like this alignment circle tool. The center of the circle snaps to graphical shapes. When the center of the circle gets close to a line, it snaps to it. It also snaps to corners, as we see when it is moved near this triangle, or to line endpoints. To construct a trapezoid, we add line segments to the scene, snapping their endpoints to the red dots on the alignment circle. Tool parts may be created dynamically. For example, this font size tool creates a font size controller next to each text string. Each region displays the point size of its associated text string. Clicking on the right arrow makes the font larger. Clicking on the left arrow makes the font smaller.
In summary, we have shown many see-through tools that demonstrate how tools can vary. We have shown click-on tools and click-through tools, tools that respond to simple straight strokes, tools that respond to unistroke gestures, tools that transfer data both from and to applications, tools that enable graphical macros and customized user interfaces, and context-sensitive tools that change as you move them over objects in a scene.